All right, and lastly here we've got a similar problem, but this time rather than figuring out how long it's going to take to double, we're going to be figuring out how long it will be until we have only half. And so this is going to be, here we go, a radioactive isotope has a half-life of 5 days. What the half-life means is that half of the substance decays in 5 days. If the half-life is 5 days, then after 5 days, half is gone. If the half-life is 3 months, then after 3 months, half of it is gone. That it's decayed at a steady rate, and that after whatever the time period is, half of it is gone. And that's something that's used a lot for, again, radioactive materials. I think sometimes just for various chemistry and medical type issues. But here we are with a radioactive isotope. So we know that our amount as a function of time is equal to the initial time, a sub naught, and then we're going to figure out our b value here, thinking back to the equation we most recently learned, figuring out how long until we get to multiply a sub naught by b. And so to do that, we've got t divided by, well, how long are we saying it's going to take? We're saying it's going to take 5 days. So our k value, in terms of the equation we had earlier of t is equal to a sub naught times b to the t divided by k. Our k value is 5 because that's how long it will take until we can just multiply our initial amount by b. So here we go. Let's rewrite that as a of t is equal to a sub naught, and then for b we want our b to be half. So sorry, I probably should put in half earlier here. So 1/2, then that 1/2 to the t power, t divided by 5 power. So we have 1/2, and then that 1/2 is to the 1/5 power, and then that all to the t power. Because remember, if we were just multiplying this out, t times 1/5 would give us t divided by 5, but we want to break it up into a little bit smaller pieces. And so I'm going to grab our calculator, and this time we have 0.5, 1/2. Now that to the 1/5 power, which is 0.2. So 1/2 to the 1/5 power gives us 0.87055. Let's just go with 0.87. So this is a of t is equal to a sub naught of 0.87 to the t. And now I hope you've noticed with a couple of these that we haven't filled in a sub naught because it doesn't make a difference about how long till we're either doubling or dividing in half in this case. The actual initial amount isn't the thing that changes it. What we're looking at is the rate of either growth or decay and the amount of time. That a sub naught doesn't affect how long that happens to double or to get cut in half. So that all being said, we've got a of t is equal to a sub naught times, well, that 0.87, that's 1 minus 0.13, so 13% to the t. And that was the question. What rate does the substance decay each day? Our rate is equal to 13% per day. All right. Hope that helps.